Today's problem, lexicographically largest string after deleting k characters. Difficulty medium. Accuracy is pretty high. Given a string S consisting of lowercase English letters and an integer k, your task is to remove exactly k characters from the string. Resulting string must be the largest possible in lexicographical order while maintaining the relative order of the remaining characters. All right. Examples. If we get an input string writ, then what we would want to do is take out the R and I, and we would be left with TZ, which is it actually itemizes all the ways that you can remove two characters. And yeah, TZ is the lexicographically largest string. For a string zebra, we can remove three characters. We would want to remove E, B, A. We have ZR. That is the largest string. Let's see. The string size can be between 1 and 10 to the 5th, 100,000. And K is greater than or equal to 0, less than the size of the string. Expected complexities, O of n. Okay, so that means we get to take one pass through the string. Topic tags, stack, strings, greedy, data structures. Let's take a look at an example here. Actually, before we do that, this is kind of unusual. Oh my gosh. Oh, now it shows up. Oh, now Java shows up. Okay. You know, I did this before, as recently as 5 minutes ago. And the only thing that showed up in the dropdown was C++. And so, yeah, I actually coded a C++ solution. I didn't run it yet, but I would have preferred to write it in Java because I'm more familiar with Java. But we're going to use the C++ solution for this. All right. Let's look at an example here. Zebra. Okay. So whatever the first letter is, we're going to take one pass through this. Whatever the first letter is, we're going to put that on the, you could call it a stack, but in C++ we can use a string like a stack. Next letter is E. All right, so we want to look and see, is E less than Z? And it is. If it's less than Z, we're going to leave Z there and put E on the stack. Next letter is B. Is B less than E? And it is. So we're going to leave E there and put this B on the stack. Right? Next letter is R. Is R less than B? It isn't. So let's get rid of it. Right? It's a greedy algorithm. It's got to be linear. It's got to be greedy. Now, is R less than E? No, it isn't. So let's get rid of that too. Is R less than Z? Yes. All right, so we'll put it on the stack. And then we get A. Is A less than R? Yes. We'll put that on the stack. And we're almost done. The thing is, we've only removed 2 letters. So we get to remove one more letter, and what we're going to do is just remove letters from the end of the string, and that is right here. So we get ZR. All right, so let's look at an implementation. All right, here it is. So we're going to create a string for the result. And for each character in the yeah, I guess that's visible. For each character in the input string, as long as the result is not empty, and we still have deletions available, and the last character in result is smaller than the current character, we are going to remove the character from result. So that's what happened once we got Z and E and B, is result's not empty. We are not out of deletions. And what we have now is a character that is wait a minute. Yeah, greater than, a character that is greater than the last character in result. So that's when we hit the R in zebra. We had Z, E, B. We hit the R. All right, when we do that, pop the stack or remove the character from the string. That means the B is gone. Decrement the deletion count. Now we're still in the while loop because result is not empty. We're not out of deletions. And we still have a character in result that is less than R, and that is the E. So remove the smaller character, decrement the deletion count. That's when we hit the Z. All right, so now this last, the last test is no longer true. Z is not less than R, so we go down here and we put R on the string, put the current character on the string. All right, once we've processed the whole string, we check and see if we are out of deletions. So if K is still greater than 0, and we need to remove exactly K characters, then we are going to, I can't think of why result would be empty since K has to be less than the size of the string. I don't know, just a sanity check. As long as K is greater than 0, we'll take characters off the end of the string, decrement the deletion count, and then return the result. That's it. And let's go over here so we can see what happens. Submit. That was fast. Gee. Okay. All right. That's it. Like the video. If you subscribe, then you will get problem of the day in your inbox. And we'll see you next time.